Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to look at how interactions work through STATA. So let's switch to STATA. Before we run the interaction models in STATA, there's something important you need to know. There are two ways to create interaction terms in STATA. Understanding both will make you a much more confident user on STATA and also will make your own life easier when it comes to interpreting the results. In this video, we're going to use a different data set from the ones that we've used for the examples in R. In this case, we're going to use the GPA data set, again, from Wooldridge. This is a data set that contains 4,137 college student information on GPA, SAT scores, high school background, and demographics. It's also a data set that is quite used in the Wooldridge book to explain quite a lot of the intuitions behind interpretations of the different variables. We're going to load the data by installing the BC use, which is like for Boston College, and we're going to use GPA2 as the data set in here. The other way is it's very easy to find also online the actual data set GPA2. So if either you want to do it by using the system data set or by having the actual data set, it's totally up to you. We can look at the data just like we've done in the R videos as well. We can look at simply what we have in general to get a good idea. So we've got here float variables for most of the information that we have, and by looking into summarize, we'll be able to point out more easily which of the variables in here are dummies and not. So for instance, we can very clearly see here that athlete goes from a minimum of 0 to 1 maximum, so that is a dummy variable. Also female and white and black, these are all also dummy variables. We can very quickly see through the code book, for instance, like to further make sure that we indeed have dummy variables in here, because usually you might be accustomed to seeing dummy variables as byte variables instead of float variables. So there's other ways you can make sure of that apart from looking at the data one by one, but the code book gives you like the unique values, which is just 2 of them. So you know for sure these 2 variables, female and athlete, for instance, they are indeed dummy variables. So let's look into the first approach, which is to manually create the interaction variable. And we're going to try and answer the question here, does SAT score predicts GPA differently, basically, for female students? The first way to do this is to literally create the interaction variable by ourselves. What that means is that in the data set in here, we don't have for at the moment the interaction. We only have all of the variables that we have seen. However, we can create a new variable by simply multiplying the 2 variables of interest. In this case, let's say we take the SAT score and female. So we're going to do generate SAT female and we're going to see right away in the data set that we have actually created now a new column in here that is this SAT female interaction variable. You can also double check by looking at random values of SAT and female in here, but everywhere female is 0, you're going to have a 0, and everywhere where you've got female equal to 1, you're going to see exactly the same number, which means the multiplication has worked. We can run then a regression, which is college GPA, the SAT female, and SAT female, which is the interaction variable. we can see the different coefficients in here. Keep in mind this at this stage we have just a level model, so depending on the units of these variables, we literally can make the interpretations of a 1 point increase in your SAT, then your college GPA increases by that beta value that we see in here. Okay. At this stage, making the interpretations is not high priority. At this stage is like learning the different ways STATA deals with interaction variables. And what you just saw is like one of the two methods, which is just creating the new variable and then simply adding that new variable into the regression. The second method, however, is by using the hashtag operator, and it's like a double hashtag operator. And the thing that I would like to bring to your attention here is that these two methods work slightly differently. Because what happens in here is that we no longer use the two variables in here, like SAT score and female. We simply use SAT and female, and we link them together by using the double hashtag operator, which is doing exactly the same thing in here, but it's doing it automatically. And the main difference is like the moment that you use the double hashtag operator, you no longer need to add the two variables here separately. You can double check also that the regression and the results that you get are exactly the same. So in here, it's not as elegant as you might see, because for what we have done in here is that we haven't really instructed STATA what kind of variables we have. So the moment that we just do it like that, it's taking literally every value of the SAT and finding how that does it. So in here, it seems like we have to do a little bit of further editing, because right now STATA is not understanding which is a continuous variable and which is a dummy variable. So what it's doing is like literally taking every single value in the SAT as being like a category for that SAT value. So for continuous variable, which in this case is the SAT, we're going to add C dot in front. So continuous variable SAT. And female, if we leave it as is, it's going just to take it like as a categorical, or in this case, dummy variable. So the other way to make it like, so to speak, equal on both sides is that for dummy variables or categorical variables in general, we're going to use I dot to mean like there are certain categories for these variables, so make sure you look through those, but consider the SAT variable in here as a continuous variable. Okay, so keep in mind, this is how you have to, or why you have to be careful when you use the double hashtag operator, because even though it does it automatically by so making your life a little bit easier, in the end, you have to make sure that you are indicating very clearly the kind of variable that you have to the hashtag operator. Otherwise, it takes them all as categoricals, okay? In practice, most researchers, you'll see that they use the double hashtag operator just because it's faster and also a bit less prone to mistakes, especially when you forget constituent terms like in here. So I've been kind of making the comparison all the time with R, and in the R video, I very clearly instructed like, make sure you don't forget any constituent terms. So in here, the double hashtag does that, but there is just the simple extra step that you have to be a little bit more precise with the syntax by adding either the I dot prefix or the C dot prefix. So I dot prefix for factor or dummy variables and C dot prefix for continuous variables. Okay, so if we run now again by using the correct and more specific context, you'll see that the table that we have in here is a lot nicer. I'm just going to run again the previous regression just so that it's easier to scroll and check the different results that we have here. But you should expect to see exactly the same results. In here, we have SAT coefficient, the beta 0.002. So if we move to the first case that we have, we see exactly the same number for female and SAT female. So we've got 0.33 in the first one. The way that now the regression is giving you the actual names, here is like female, SAT female. In here, it's telling you the SAT one, the slope is 0.02. And then now when you look at female by itself is that 0.33. And then you've got female and CSAT, which is the minus number in here. Okay. So you can run, so in essence, you can run any of these two like regressions, and you should be getting exactly the same bit of information, okay? Keep in mind the beta 3, so in the first case is this SAT female that it's giving you that information. In here is this female hashtag CSAT1 that it's like your difference in slopes basically. And the 1 dot, it's literally your difference in intercepts, because that's when the difference when SAT is equal to 1 compared to when SAT is equal to 0. But again, as we know, when we have interaction models, the beta 3 is what is the most important for us. So in this case, these two numbers here coincide and is what we are going to also concentrate in the next video to actually see what is happening. Before we finish this video, also to give you a heads up of like, how do we actually compute the marginal effect? Because in all of the theoretical videos, we always do the derivative to see the actual effect. In this particular case, we can compute them marginally. We can compute the marginal effects manually, just like we did in R. For that, we'll have to store all over again the betas, so we can get the beta 1 from the beta SAT, and then we've got the scalar for the beta 3. Because earlier I ran the one where I multiplied the two variables, I'm going to simply run this regression once again. So this is the last one that's been saved in the memory. And now from that, just because this is how I've written the code, we're going to use these two to save the two betas. This is the effect for male and this is the effect for females based on the derivatives that we now should be very familiar with. So beta 1 and beta 1 plus beta 3. And ultimately, this is going to display for us the effect of the SAT for males, which is effect male, and effect female for females, and the difference beta 3. So this is no new information. We've already seen this in the table in here. It's just a nice way of representing your results by using like strings and isolating just the betas that we're interested in, which in this case is like the 0.02 and the effect for females, which would have been the 0.02 plus the constant in there. And then we've got here the difference in the beta, the difference between the slopes, which is simply directly the beta 3 with no need to make any further computations. There is also another way you can compute the margins, and that is by using the margins command. And it's a very powerful tool in STATA, and it's used not only for simple regressions, but also, especially when we'll dive later on, also on probit models where you can't interpret the betas as they come out in the actual regression. So in here we can do, to find the margin effects, we simply get margins female, and the actual syntax is dy dx, so margins derivative as we've done so far, so dy over dx with respect to the SAT score. Okay, so if we run this again, we're going to see in here the marginal effects, so the deltas in here. What you will notice is that you should be getting like the separate margin effects for males and females. You're going to see that for the row here where female is equal to 0, this is the effect of SAT for males, which you will very clearly remember it's exactly the SAT coefficient that we got in here. And then for females, as you notice, is the 0.00199, which clearly doesn't show in the actual table in here because that needs to be like calculated. Because remember, for female, this was the difference. It was not the final answer. This would have been computed as we did previously in here, and effects for females is this beta 1 plus beta 3, which should be the 0.00199. And this is also the reason why you see here the 0.00199. Okay. To make these comparable also to what information you got from R, you can also do the visualization part in STATA as well. The margins in here plot command will be able to show us exactly that. So let's have a look very quickly. Okay, so it's a very weird graph in a sense, because keep in mind here you don't have a continuous variable, and you're looking it for with respect to male versus female in this case. So the margins in here or this graph in a sense is a bit of a useful tool just to really see the differences between the two groups. If you really wanted to see instead the actual fitted lines, then you would have to do the same process that we did in R, where we need to predict the fitted values first and then plot the two fitted lines. So if we do just that through the two-way, you can see here the actual lines. So from the graph in here, it does seem like the two lines are quite parallel to each other, which would mean like actually that interaction is not really adding much to it. Non-parallel lines would confirm that the interaction is doing something. And if there is like a gap between the two lines, it means that it changes with the SAT score. Now, obviously, if we look just at these visually, we might also make mistakes, because it does look like there is a little bit of a wider gap down here compared to here. So it would seem that it's not exactly parallel, which is we can do a test to see whether beta 3 is actually significant. So we've got here, this is what testing beta 3 is like. So this we could have checked directly also from the regression, because in here we have the beta 3, we can look at the p-value, we can see that the p-value is actually quite high, which would mean that, well, yeah, we've got a statistically insignificant variable, which would mean that what we saw is like the graphs being sort of parallel, which means that there's not much of a difference between the two groups in terms of the slope. Okay, so here we would basically fail to reject the null hypothesis that there is a difference across the two groups in the slopes. Okay, you should always test this before interpreting any interactions. Sometimes you will be asked to do the interpretation as it is, whether it is statistically significant or not. In most dissertations, for instance, students always do the interpretations for the numbers that they have, and then simply add another sentence that, hey, although this is the interpretation, this is statistically insignificant, and then continue to make like an analysis of what that would mean for their research. Okay. Overall, what you should have gotten from this video is that in STATA, there are two ways with which you can work with interactions. So always be very careful with which way you are working, because the tools that you have then to work with are also going to be different depending on the method that you're using. You can either use the manual way where you create the interaction by multiplying the two variables, or you can use the double hashtag. Um, they should give you both identical results. It's just that the hashtag combined with the margins gives you quite a few options, especially when you're doing research or writing your dissertation. I hope this was helpful, and I'll see you in the next video.